Hi, I'm here again on the ARC Advisory Group Digital Transformation podcast series. I'm doing a series where I'm really digging deeper on all topics AI, and particularly areas, the foundations we need for AI, like industrial data. This is the second in a series of at least three. Who knows, Rick? We might get to four or five. But this is the second episode on really industrial systems engineering in the era of AI. In part one, we kind of laid the data foundations before the AI boom and all the challenges that we've been facing and to a large degree still face after 2 decades. If you please listen to part one. And we did a deep introduction of Rick on that one, advisor, investor, mentor, and a long-time personal friend. And let's jump into part two. I think we obviously covered, Rick, the long history and some of the acquisitions of some of your early investments and coaching, steering those companies to acquisitions. So I think that really painted a picture of kind of how the market had evolved, in some ways I would argue stagnated. And then now with AI, there's a huge renewed focus on data quality, the fact that we have different challenges in factories and supply chains with massive amounts, frankly, petabytes of data, which in many ways goes underutilized. So that maybe in this part two, let's kind of dig into now, how are we seeing that new era of AI? And we've talked about this a lot, Rick. AI is not new, but kind of triggered by that November 22 moment with ChatGPT. Now that people have rediscovered and expanded the footprint, the whole toolkit, which now includes Gen AI, let's talk about how things have evolved and kind of the new. This is about systems engineering, after all. How's it impacted? In some ways, set us back or moved us forward? I'd love to hear your thoughts on that. And we'll get into kind of I'm obviously doing a lot of work on data fabrics, or particularly industrial grade data fabrics. So we'll get to that. But maybe just start with that basic premise of what were the big things that you've seen kind of just changed since November 22?
Well, one thing, just the one big picture item. Before, we were able to do a lot of stuff leaving the data in its source systems, right? When the focus was visualization, integration. While I guess that's technically feasible with some backends in the AI world, for the most part, it's a lift and shift thing now too, right? If you look at a lot of the data ops players, the cloud players, and some of the infrastructure they're building, it's now let's take those petabytes of data, get them to the cloud, spin some meters in the cloud. But storage, as I think we talked last time, we assume storage is approaching free, right? It's not free, but it's close. So that's less of the impediment, but getting the data out of the source systems, I think we addressed that last time. Not the obstacle it used to be, right? That's kind of well in hand. Realizing it, that now we have a fundamental issue. We're trying to build these multi-stream data warehouses, data lakes, data ponds, data puddles, whatever you want to call them, in the sky.
Data swamps, I think I've
seen quite a few of those. So getting the contextualization, I think post ChatGPT, it addressed we wrapped up last time with a lot of discussion about unstructured data, right? Textual data. Still not a trivial problem. It's not magic, right? That it can interpret your weird proprietary operating procedures or whatever, but it's getting pretty close. There's some really neat stuff going on there. So that's one side of it. I think the other thing that's changed maybe is even if we go to the AI work that was being done, a lot of it was kind of predictive around time series data, multi-stream state data, and trying to get some insight out of it, right? Now we're operationalizing it more. It's actually taken, so that connectivity, we have data coming up. Now we're starting to see a lot more where you're actually sending stuff down to the source system. So secure connectivity to the either a human or those systems, that's a challenge. It's a cybersecurity challenge to deal with. We still are dealing with, as you said, the law of large numbers. It's an enormous amount of data, right? And you've got this, remote plant in the middle of nowhere with a low bandwidth connection to the outside world. Maybe Elon can sell them some Starlink, and we'll solve that problem. But it's not trivial, right? If you get that kind of volume of data. And then now we have like a whole new set of terms, right? Industrial data ops. There's everybody's PowerPoint looks like they do it. Everybody has the need to do it. So new submarkets popping up. Almost every week it seems like. You mentioned how that was a seminal moment, right? When ChatGPT hit the world. The question I think we won't really know for a little while is the pendulum always swings too far, right? So now everybody's trying to throw time series data into, is that really is a language model or other, how can we leverage,
right.
These kinds of things? I think the other recent change that's worth talking about, from an architectural standpoint, is that you don't need to always bring that data into a data lake, data swamp, right? With MCP, which you've been writing quite a bit about. Can we start using these tools more as a true kind of, co-pilot, voice assistant to ask the right questions of our back-end systems? We could probably do a whole deep dive on that topic about how to do that safely, securely, and so on. But every day I see some interesting work that someone's doing about bridging into these source systems using kind of well-described interfaces. So the technical obstacles are they're getting easier and easier every day.
And I think that's what's got me particularly excited about this wave. I mean, I think we both got grey hair. I know you're hiding it under that cap there, but
yeah, a little bit.
We've been around long enough that we've kind of seen these iterations and these breakthroughs, which kind of, no, they don't really, they change a few things, but they really don't have huge impact. I think we already know that November 22 moment has had a tremendous impact. And I don't think it's necessarily Gen AI per se, or that particular large language model, right? It's really, I think, everything that it's triggered in terms of much more willingness to think about interoperability and open systems and solve kind of large scale problems as an industry, right? And I'm not just talking about manufacturing, I'm talking about technology in general. That's what excited me about kind of some of the things that happened around first Anthropic kind of donates MCP, Model Context Protocol. And then you get a consortium kind of led by Google adds agent-to-agent extensions on top of that, along with 50 system integrators. A lot of the players that really we needed to support it, because we were already asking questions about, well, we like the idea of agents, and agents going to be not having to move data. To your point, I can have an agent sitting on the edge or interrogating the edge and just getting what it needs when it needs it, right? So I think we saw lots of opportunities with agents, but we had these questions about, all right, is SAP going to create its own agents, and Aviva is going to create its own agents, and they won't know how to talk to each other. So we had that, and then AWS kind of doing something interesting with Strands, right, with really building those agents and having them interoperable and being able to run multi-cloud and on the edge. I mean,
even SAP. I mean, I looked at it the other day. It's some pretty neat stuff. So a lot of companies and that's the flip side, right? Everybody's building their own framework for authoring agents to your point, A to A and things like that are going to be essential for them to work together. Add a lot of custom coding securely. I know you've written on the MCP challenges there, but it seems like that was well thought out. At least it was considered deeply in A to A, which is encouraging.
Right. Yeah. And obviously we expect to see a lot more iterations of that, as we should, for identity security, whole host of reasons. But I think the other thing you triggered as you were kind of responding on your initial thoughts was really, and I'll dig deeply into this in my industrial data fabric reports, the fact that there is still this, I think, recognition now that you don't have to ingest all this data into a data lake somewhere in the cloud, that we can leave a lot of that data, whether it's Delta Share and things that kind of Databricks, again, I think they have momentum because they offered it up as open source, right? But I think the fact that you don't have to move all of that data to the cloud and we can start using it on the edge, which, by the way, our data was showing, last year there was this swing back to the edge, at least in the industrial sector. They didn't want to, because it's damn expensive, right, to move all this data, particularly if you don't know what you're going to do with it and you're just moving it because somebody in IT said, I want it in Snowflake, right? And then all that time series data there, no context.
Or you made a $30 million a year commit to your cloud vendor.
Right. So you need to use it.
Similarly, like also uniquely to the industrial space, right? Where are you executing those models? What's the high availability considerations, all the usual stuff. I think the other thing we didn't touch on that was also the light bulb moment after ChatGPT and now a lot of the vibe coding and is the value. We're focusing a lot on the value maybe of analyzing the data, but I'm really getting excited about the ability to ingest all the knowledge and best practices about configuring and building our systems. Now, just think of when you do an industrial automation project, PLC coding, SCADA, HMI configuration, historian setup, so much of it is grunt work, right? Well, what a great opportunity then. The best practices have been established over the past 55 years. Let's encapsulate those, give people the superpower button to turbocharge button to do that configuration. Then I'm starting to see a lot of interesting work as well.
Yeah, and actually I've done a couple of podcasts with Dustin over at Seek. And we touched on this a couple of times, which was really, they kind of have some great tools for exploring time series data. But a lot of what we were getting into was kind of the idea of Gen UI, right? Which was really that a lot of I think for us, at least in our sector, to your point, is we deal with very complex systems, lots of configuration, because they're not highly standardized processes that I can have a best practice for today, right? And code that nicely in a ERP system, right? Where it is all about highly standardized processes. And so in many ways, that's been the biggest barrier to doing things like, having MES at scale. I'll just use MES as an example. I think we could have another episode just on what is the future of MES, but the fact that never really took off because it was too much configuration, lots of expertise needed because every system was very complex. And to your point, Gen UI can take all of that away if done right, right?
When we started, I think it might have been the Lighthammer era. It was either Lighthammer or ThingWorks. Russ Fidel, my partner, had this light bulb moment one day that I remember the iceberg visual he had, that we have all the codified apps that we build, but there's opportunities for transient or temporary apps, right? We've got a problem to solve. We've got an opportunity. And if you put them through the traditional IT pipeline, it's going to get done when it gets done.
Or it's changed by the time it does get done, right?
Right.
Yeah.
So we built tools to allow, less technical people to build those kind of ad hoc applications. But the Gen UI, Gen AI concept says, let a even less technical user describe a situation, whether it builds an app or it even says, hey, in the situation you're in, I think it might be useful for you to see how you're performing right now versus perfect conditions. So it automatically generates. So that ad hoc experience, as opposed to even just helping you build more permanent apps, is another very, very valuable area.
All right, let's maybe talk about. I think we need a little bit of structure to the conversation. So my first question was supposed to be. We've kind of, and you touched on the language, all the language has changed and we used to talk about data historians as almost the be all and end all or enterprise manufacturing intelligence, right? Now I think really how I'm trying to describe the problem is industrial grade data fabrics as describing that wide spectrum of needs. And I don't have AI in there, but there is obviously a whole bunch of those requirements are kind of driven by the whole life cycle opportunity to build AI apps or agents. And because to your point, they may not really be apps in the traditional sense. And there's definitely a role for kind of low code, no code, both in creating the data fabric, but then also in the delivery of those apps, agents, services, next generation of APIs, whatever they are, right? So let's talk a little bit about this idea of what is an industrial grade data fabric that lets you do all of this cool and exciting stuff that you see coming with AI, vibe coding, all the buzzwords. I probably can just fill out the rest of the podcast. We'll just throw out buzzwords, right? But let me give you a chance to respond to that. What do you think is an industrial grade data fabric? And does anyone have one? I don't think so, but
question is, well, what is it functionally? And then separate that from the implementation, right? To me, an area that I think gets glossed over a lot is the importance of discovery. Like there's the access to the data. There's also access to the metadata, the data models, all the elements that enable people in tooling, particularly tooling, whether it's AI assisted or, some kind of analytics environment or whatever, to understand and comprehend that. Now we've got, and then for all that to work, you need some level of normalization, right? Everything in degrees F, it's common data formats at the consumption layer. So how do you consume it and discover it, consume it, do transformations and things like that on the data, particularly as multi-stream contextualization, all that stuff. Separate issue is, where does it live? Does it all get dumped into a data lake? Can it be kind of ad hoc? Are you using compute to do a lot of the work? Do you use the data source to do? We've seen obviously big changes in how we manipulate data at cloud scale. Like that's a big shift for sure. So yeah, it's again, it's got to be able to get the data in, have access to the data, whether that's shipping it up, lift and shift, whether it's on demand, unified kind of data representation, unified meta model, codified data models where they make sense. I'm not so hung up personally on the S word standards. Mm-hmm. Great. That's awesome. I think it's like standardizing data schemas for a filler or a pump. Or it sounds good. It just never passes the reality test, right?
Yeah. Look, as you know, I've been engaged with standards, and I guess I got very frustrated with them that you would spend years working on something, little or no impact, right? I am one of the advisors to SESME, and I think they're doing some interesting things, probably the best I'm seeing out there from a, right? And sorry, I forgot, Rick, yes, you got me on there, right? So I think they're doing some really cool stuff, but to your point, I think they should keep doing it because we need as much help as we can get on kind of the unified namespace that we still don't have, right, in kind of factories, and any progress we can make is better than just the Wild West right now. But to your point, I think I see more impact of things that are coming from hyperscalers or obviously big vendors that just have enough of a impact on their ecosystem. That's where I look, because that's where it actually happens, because there's money involved, and
that's a double-edged sword too, because you obviously want the bigger tech companies to engage, to participate, to provide high-level services. The risk, and this is as old as the dawn of the computer, is when big tech announces something and it's not really there, right? That it's
sure.
We get a innovation winter, right? That's like people stop their spending. The smaller vendors who have solutions ready to go today kind of go into this,
get stalled, right? Yeah.
So it's good and bad.
It's a double-edged sword, I think, and I agree with you there, and I could give lots of examples of that. And in some ways, that's why I'm writing an industrial data fabric report, because everyone claims to have one, right? And without mentioning any names, there's at least 2 hyperscalers that have something called a data fabric in their mix, right?
I think they all do functionally, right? They just call it different things. They'll have a slightly different take on it.
Right, and so but what I see in practice is that larger enterprises that have enough IT and OT resources are assembling what I view as an industrial grade data fabric that has a lot of the elements you're talking about, where it knows, and very often it's I won't quite say a hard line between the factory and the enterprise, but that's where the most activity is in terms of assembly, making choices. Once you get above on the enterprise side of it, it tends to be the snowflakes and the Databricks and your enterprise vendor. So if that combination is much more limited, much more predictable, and depends, I think, if you're more IT focused or data science focused on which selections you could make, or outcome focused maybe is another way to look at that. But on our end of the spectrum, it's a lot more fragmented, and people are having to assemble individual pieces. Oh, right, I need a unified namespace. Who am I going to use there, right? I've got to move data around, and you decide whether you feel like you have to move it, or you just have to know where it is and it's described by so there's lots of variations I'm seeing, right? So maybe talk through some of those that you're seeing, because I know you're actively involved with a number of those.
It's a big organizational question too, right?
Yeah.
The value we unlock I would think, would be amplified when we have access to both the enterprise and the master data and the procurement data, who we source those materials and parts from, and then how it performed in production processes, on which machines that we license from. There's lots of use cases where you need both, exactly. which is a big chunk of my driving force for saying I need these to come together somehow, right? Which, in my opinion, and I've seen people try and push a rope the other direction, that needs to be owned by IT, right? Because you're not going to. Is the OT folks aren't going to be given carte blanche access to suck all the data out of their ERP and other enterprise systems. That's an area where there's going to need to be some collaboration, right? Whether it's on-site, whether it's cloud-based, doesn't really matter. It's an organizational challenge to get those. And then you have, again, same data normalization problem, exists. The industrial data ops folks seem to be like their special sauce is still connectivity to the weird stuff that we deal with, the normalization, time, all the kind of things that we've always known are unique about industrial data. I think we talked about all of that in episode 1, and that's kind of where a lot of them still are. It's just now called industrial data ops, right? It's not enterprise manufacturing intelligence anymore, but some of them are doing some interesting things in the way that they're doing it, in that there is some smart tools. They're even using some aspects of AI to help
gather that data, and then I tend to, and this is where I think you see those that are very much stuck in that pre-AI era, and then those that are either using some of the new technology to help build the models faster, or provide insights faster, and then those that are actually thinking about the connection between industrial data ops and industrial AI ops, right?
So to that end, that's an area. I don't know if you've seen some of the videos that Aaron from High Bytes proposed, but they're pretty good about. Okay, we talk about a lot of the industrial data ops was lifting and shifting all our proprietary data, getting it to where it needs to be, cloud data, Snowflake, Databricks, whatever. Now it's enabling the ad hoc. Okay, we know how to talk to those things. We know how to transform data. We know how to provide structured schemas around it with the data ops tools. Now, how can we expose that using something like MCP? Right, so you don't have to worry about the last foot connectivity. You don't have to worry and even things like MCP benefit from structure, right? It's not class, right? So having some data models and data exposed, and then being able to plug in these different standard interfaces is a pretty powerful way to do it for more of that ad hoc kind of scenario.
Yeah, and I see a lot of them working on their MCP servers and clients, and I think that opens up the agents access, and it's going to be a fun. Sorry.
And giant security holes.
Well, and that's a lot of what they're trying to fix, right? In the short term, is right. We'll have to solve the limitations of the first gen, right? And I know Aaron and a few of the other guys gave me feedback on what they were doing, and you and here, a lot of folks. With the other guys, XLM Pro, is it? I think if I got their name right. So they're doing some interesting stuff there as well. But what about right? I mean, I've got pictures we can share and articles I can point people at, showing you kind of what are all the different potential pieces of a data fabric, and that's really my next report. So what I do want maybe you to talk a little bit more about is the connectivity, which we started talking about with how it could change with, you got the data ops players solving that problem, but then maybe exposing it in different ways. There are more data types that I think we now expect them to deal with, like particularly video, and then the unstructured data, right? So I think there's the connectivity as part of this nervous system that's helping you create this data fabric foundation. And then there's the edge, right? Where does the data live? We've touched on it a couple of times, but it's kind of like some thoughts on when can that data stay on the edge? And when does it have to move and be ingested, right? Because we got petabytes of data and we already know it's too expensive and you can't move it without any context, or you can, but a data scientist is not going to know what to do with it, right?
Well, I think we discussed in the last session, raw data often in our world has a very short half-life. If it's not used for compliance or something where you need to archive it for a long time, its relevance decays pretty quickly, right? But what is interesting about it? Is it the outliers, the extremes? Is it the statistical aggregates? Another area that I don't think gets touched on enough is what I call synthetic data. And synthetic data is kind of the calculated stuff. And that stuff might be a simple arithmetic calculation. It might be applying, AI machine learning algorithms to imagery. It might be doing it to a bunch of data streams. Then the output of that becomes the interesting piece of data. So often it's the processed data that has the insights or the events or stuff you're trying to compare with other sources of data to get insights. That's really lends itself, well, it depends. It lends itself certainly to edge processing for executing those models, calculating, right? sometimes you still need to, today, you still need to lift the data somewhere else to do the training. If you're training a machine learning algorithm, right? It just,
And it's better if you get it from lots of different similar machines, or I mean, there's some models you need to aggregate the data, and you need some compute power to kind of create those models, and then you may push the models back down to the edge for execution. I think that's reasonably well understood, and there's some use cases where that makes a lot of sense.
well, similarly, compute for like now it's great. That works. This all works well for brownfield. How do you do this stuff for greenfield stuff, right? You don't have 5 years of data to start from. So starting to see next gen simulation environments, and can we use AI to help rapidly build those simulations based on, first principles and prior knowledge, and
Or hybrid, right? Yeah.
yeah, fascinating time.
Yeah, I think and that's an interesting point, because I talked with Chief AI Officer at Schneider, and he was talking about how they were looking at different ways of, when you put in a new piece of equipment, you don't have an AI model that's been tuned for that piece of equipment in that particular application. And so what techniques do you use to kind of start and then iterate and refine the model over time? And some of that may involve kind of a federated approach, where you're kind of sharing it. And this is, I think, maybe one of the next waves that we will see in the applications we have, with lots of distributed machines and devices, and there's always that hesitance to share the data. But if we can solve the kind of federated learning problem, then that might open up a whole host of new opportunities, right?
I also wonder if there's a Pareto opportunity there with the machine builders, right? The people that build the paint booth or the fluid bed dryer or the bioreactor, right? Number one, they have very, very deep process knowledge about that. They provided the equipment, and so it's a natural use case for what you talked about, where you go across a population of machines that span organizational boundaries, right? All the pharma companies that use the C65 123 machine agree to anonymously share their data, and then they benefit from the insights that come from that, right? We've always heard that and it does happen. There's some, but maybe that's an easy enabler for that. Is it's still going to be somewhat isolated, right? To what the machine vendor knows, but it's a start.
It's better than the status quo, right? Yeah. So I think we're somewhat in agreement that not all the data needs to move to the cloud, because it's really its half-life, as you said, is kind of fairly short. So unless it's being used for control or somewhat, and a real-time term is obviously always very dodgy, right? What is real-time enough? But if it's not going to be used to optimize that process or keep it safe or compliant, then a lot of it, yes, there's lots of it, but that doesn't mean it's very valuable after a few days in some cases, right?
But you don't want to ignore it, because what I have seen this happen a few times, where it's still often best when you're training machine learning algorithms or whatever, the more data, the better, right? And nowadays, a lot of the auto ML and other techniques will help us say, oh yeah, these are the signals that matter, right? These are the sensors and data streams that matter. Here's the significance to the outcome. So, do you remember, this is an interesting one. Do you remember the early Pavilion? Remember the company?
Yeah, Pavilion Technologies, yeah.
Right. So one of their early value props, and it was some neural net stuff and other AI techniques, was they would use sensors in smokestacks, right, and build an accurate model that predicted what was going out the stack, to the point where you could remove these very, very expensive
analyzers, yeah,
sensors, right, that required a lot of maintenance and precious metals anyway. So the idea there was, we don't really know what affects necessarily initially what affects that. Now you can do first principle stuff, but feed as much of the data in, get the significance, and to some, you might find stuff you don't even need to measure anymore, right? So.
Yeah, and I don't want to be too prescriptive, right? There's always a tendency that we're missing use cases because they haven't actually been discovered yet, right? Until people rethink the technology, which, again, I think is a whole other topic. I see lots of people equating AI agents to tasks or people, and I think that's a bit myopic, right? And we'll talk about robots and whether they really need arms and legs and stuff like that at some point. Rick, yeah.
But the agent, I mean, well, that's a whole other topic, the whole agent thing, but it does tie back to all of this in the sense that at some point, those agents may be also our data guy. Like they may be the gophers to go get the data, right? For other AI components. So instead of someone having to pre-curate and, they're going to become the new APIs in some ways.
Right. Yeah. I see lots of potential use cases where I think the most fundamental one will be that they will be monitoring and maybe looking for exceptions or patterns that may need exploring, right? And then you'll trigger a workflow and maybe a request to, all right, well, I need that batch of data so I can go and see whether there is something there that justifies what you were saying earlier, a quick app or a quick exploration to solve a problem, or just say, okay, that's actually just normal deviations and it's not much value in pursuing it any further. I think we'll see lots of interesting ways of leveraging agent technology. I think on this one, we've jumped around a lot, but I think we were really trying to start thinking about all the things that are changing in this new era of AI and some new complications around the data problem. And I think we've covered a lot of those. I think data governance, security, reliability of the fabric. I think those required almost dedicated discussion. But it sounds like you had some maybe thoughts to help start closing this one.
Well, I was going to ask you a question. Like one of the big debates is whether data quality matters, and it's a fair debate. Can AI techniques and technologies help us solve that problem, or does it need to be perfect data before you put it in? That's an almost religious debate in some circles right now.
Actually, yeah, this is probably a good one for us to maybe explore, and then we'll call it a day for episode 2, right? But I think, yes, and you're right. It is it's like religious, as you say. It's like if I talk to somebody who's passionate about lean, they can't accept that there is anything other than lean approaches, right? And I don't want to do any political analogies or anything like that, right? But I think the data quality, yes, I've heard both ends of it. It's kind of like, do I really need to go and build this data fabric before, and then I'm going to run everything through it, and so I won't make any progress probably for 2-3 years, right? Or is there an approach where I just look at the data quality I need for each use cases, and I use each use case to kind of start building up that future data fabric over time? That's one aspect I'm hearing is let me solve it. And that's not just about the quality, that's about how much of this do I need to how much of a unified namespace do I need? Can I just do it around assets because I'm solving a predictive maintenance problem, right? And that's where I'm going to make my initial push. But the other one, I think to your point, is how good does that data need to be? Does it need to be 100% perfect, or a lot of the AI can filter out a lot of the extraneous stuff, or at least tell you there's a confidence level, right?
Help us identify where we might have a data quality problem, right?
And it's funny, I was talking to Aperio, right? And that's their primary focus, right? Is just look at the data quality and say, is it good enough? What confidence? Or here's how you clean it up. And that's their reason for being, right?
And it's a non-trivial thing because we've all probably encountered in our career a situation where someone made a knee-jerk decision that's bad data. It might not have been bad data. It might have been a true outlier. And sometimes the noise is the signal, right? So sometimes we dumb the data down too much before we ship it to the data lake, and we've lost a lot of signal. That's always a risk as well. Losing fidelity, losing signal, which you inherently do, if you're just sending up simple aggregates and things like that.
Yeah. Even the good old data historian is doing a lot of compression, right? Maintain most of it, but we all know the limitations of some of the algorithms there. That's probably a good note for us to wrap up. I'll let you wrap up with some thoughts, or is it another question for me?
You precipitated a thought, though. You said that a lot of the work underway right now, and this is true, is very asset centric, right? And I postulate that a lot of the big value, potentially a multiple, is the process, right? The process analytics. But if you look at kind of all the approaches to, on the industrial side, typically how we model our data and our data fabric, it's very asset centric. ISA 95, hierarchy of assets and thinking, and some people are doing the process side of it too, but maybe that area needs a bit more attention overall. And how do you define process models in a more standardized way, and the components of what make up a process, and materials and inputs and outputs. And again, the standards do address that. It's just I've not seen that show up so much in the data models that we're using in the data field.
Right. Yeah, I can't say off the top of my head. I suddenly think of the S-word standards that kind of describe, I'm a chemical engineer, right? If you go far enough back, right? So yes, music to my ears. I always think about product and process life cycles. And to me, the process, yes. And I think we know why we're so asset-centric, right? It's kind of something tangible. It usually is the thing that has the sensors on it, right? You can kind of make a case that I'm really going to take a subset of those assets that are worth some money and can impact the process, but it's kind of a roundabout way of kind of prioritizing based, I think, on how it's evolved, right?
I wonder if it's also a side effect of what we touched on earlier, is the organizational divide, right? Because some of that process context may require more enterprise data than the asset point of view does.
Yeah, that's always the case. Use cases I used to bring were really around how we needed cost information. We might need energy data. We need the schedules to know whether we're actually performing against schedule. I mean, there's lots of data that really is more about how, why, when, and the quality of the stuff that's flowing through the process. It's not about the asset. The asset is just a way of making the product, right? For most of us, right?
Moving and changing atoms. That's what they.
Right. Yeah. Now we're getting too philosophical. It's probably a good time for us to wrap this one up. Rick, as always, a pleasure talking to you. We'll kind of move on to at least one more. I suspect we've got 2 or 3 more, depending on how many tangents we want to take on this topic of systems engineering in the era of AI. And maybe it needs to be, we'll do these 3, and then maybe we'll do some, because things are moving so fast, it might just be, oh, right, let's do one on this topic because it's another one of those that's come out of the blue and people are trying to decide whether it's got legs and they should be paying attention, or whether they skip this one or at least pause on jumping too far in that direction. So maybe we'll take that approach. But once again, thanks.
Pleasure.
Thanks, Rick. I've been talking with Rick Bellotta. a advisor, mentor, serial entrepreneur. I don't know how many words I can use to describe him. That I always check in with on what he's seeing across the industrial systems arena. And hopefully you will join us for part 3 in this podcast series with ARC Advisory Group.
Thanks.
Thanks all.